This is Honors Geometry Lesson 2.6, Proving Statements about Segments and Angles. First thing I want to talk about is what is a proof? A proof is just a logical argument. And the logical argument is going to show us that that statement is true. The way we usually write our proofs, at least start this way, we write a two-column proof. And on the left-hand side, you're going to see the statement. On the right-hand side, you have to justify every statement with a reason. So let's go ahead and write our first proof. We're given that segment AC is equal to AB plus AB, and it's our job to prove that AB equals BC. So you always want to start with a given. So the first thing you're going to do is copy down your given statement into step 1, and you justify that. How do I know that's true? Because it was given. Now, step 1 leads to step 2. In step 2, we said that AB plus BC equals AC. We've never mentioned BC before, so I really don't think it came from step 1. If it doesn't come from the previous steps, then you want to go back to the diagram and see if you can see where that came from. So we're saying that AB plus BC equals the whole thing. That's called segment addition. When you add two little segments together to get a big segment, that's called the segment addition postulate. So now we're moving on to step 3. Step 3 says that AB plus AB equals AB plus BC. You can see what they did there. They used the transitive property, that if AB plus AB equals AC and AC equals AB plus BC, we don't even really need that AC. We can just state that those two things are equal. That's called the transitive property. Or if you want to, you can also use the substitution property for that. And then finally, from step 3 to step 4, you could see the difference is we're missing an AB on each side. And what's called when you get rid of something in an equation, we wanted to get rid of an AB, so we're going to subtract an AB from both sides of that equation. That's called the subtraction property. And just to remind you, what you can put in that reason column, you can use definitions. Anytime there's a vocabulary word in the given, you're going to use definition of. If they tell you have a midpoint, you're going to say definition of midpoint. If they tell you have an angle bisector, you're going to say definition of angle bisector. And of course, we're still going to use our properties, we're going to use our postulates, and we're going to use our theorems. A couple of theorems you want to make note of is that reflexive, symmetric, and transitive all work for congruence. We've only been using those for equations. Now we're going to say, hey, it also works if we use a congruent symbol. And the same thing for angles. We can use them in angles also, not just segments. All right, let's write another proof. We're given M is the midpoint. Soon as I see that, I see the vocabulary word midpoint, I know somewhere in my proof I'm going to use definition of midpoint. So we're given M is the midpoint of segment AB. So as soon as I see that, I'm going to slash my diagram to remind myself it's right in the middle. And it's our job to prove that AB equals 2AM and also that AM equals 1/2 AB. So again, the first thing you want to do is copy your given down. So we say M is the midpoint of segment AB. So the left-hand side is the statement, the right-hand side are the reasons. We have to justify every step. And of course, the first reason we have is that it was given information. All right. From step 1 to step 2, we say we now know that AM, segment AM, is congruent to segment MB. And remember, we slashed our diagram. As soon as I read that word midpoint, I said, hey, I know it means it's right in the middle. We call that definition of midpoint. The definition of midpoint is the point on a segment that divides the segment into two congruent segments. So I can state that segment AM is congruent to segment MB by definition of midpoint. From step 2 to step 3, you can see the only thing we changed is we went from a congruent symbol to an equal sign. That's called definition of congruence. The definition of congruent segments is two segments that have equal length, and that's all we're saying. If those segments are congruent, then they have equal length. Step 4 says that AM plus MB equals AB. We've never talked about AB before in our previous steps. So I don't think that came from steps 2 and 3. So I'm going to go back to my diagram. And if I look at AM plus MB, I'm saying it equals the whole segment. And that is our segment addition, saying if you add two little segments together, you get the big segment. So we're going to call that the segment addition postulate. All right, step 4 to step 5, you can see the one thing that's different is they replaced MB with AM. And there's a rule in math that says when two things are equal, you can replace them. That's called substitution. What they did is they substituted AM for MB. From step 4 to step 5, or step 5 to step 6, it looks like they added 1 AM plus 1 AM and got 2 AM. And what they did is they combined like terms. We call that simplify, or you can call that distributive property. It's sort of the backwards distributive property, but it's not the addition property. Addition property says you add something to both sides of an equation. We didn't do that, we just combined like terms. And then from step 6 to step 7, you can see we divided both sides by 2 to get rid of that 2, so we would call that the division property. All right, and we're done. Once you get to the steps where they ask you to prove, you're done. Let's try another proof. And the right hand side are our reasons. So we have 4 steps in this one. Step 1, again, always is your given. We just copy our given down. How do we know it's true? It's given. From step 1 to step 2, it looks like we changed it again from a congruent symbol to an equal sign. Again, we call that definition of congruence. If angles are congruent, their measures are equal. From step 2 to step 3, we just switch the order around. When we switch the order around, that's called the symmetric property. And then from step 3 to step 4, again, there it is. We change from an equal sign back to a congruent symbol. That again is called definition of congruence. All right, let's try another proof. We're given that B is the midpoint of segment AC and C is the midpoint of segment BD. It's our job to prove that AM equals CD. First thing I noticed is they didn't sketch this for us, so we're going to go ahead and sketch it. So I'm going to draw segment AC, and they tell us right in the middle of that segment is a point called B. And so I know it's the midpoint, so I'm going to go ahead and slash that to remind myself those are congruent. And then they tell us C is the midpoint of BD. So there must be a point out here called D, and it must be the same distance from C as B is, so I'm going to go ahead and slash that to remind us. All right, here we go. The other thing I maybe notice is that I have a vocabulary word. So you know somewhere in the proof, you're going to use definition of midpoint. And let's go ahead and write our proof. First step, B is the midpoint of AC, C is the midpoint of BD. We know that's our given. So we always copy that given down. Step 2, we're stating that AB is congruent to BC. Remember when we first read that, we slashed that. We said, I know if B is right in the middle of AC, we can say those segments are congruent. That's by definition of midpoint. Now they're saying that BC has to equal CD. Again, if you remember, we slashed our segments as soon as I read that C is the midpoint. So again, that's going to be definition of midpoint. If they give us 2 midpoints, we're going to use 2 definition of midpoints. Step 4, you can see comes from step 2 and 3. Always they did is get rid of those BCs. Again, that's called the transitive property, or you can call that substitution. It would work too. And then finally from step 4 to step 5, what they did is they changed from a congruent symbol to an equal sign. Remember, we call that definition of congruence. Oh, I think that's our last proof. And go ahead and try the practice problems. Email me if you have any questions. Thank you.